Welcome. In our previous video on the scanner class, we discussed the idea of writing an interactive application. Such an application requires obtaining input from a user. To accomplish this, we provided a brief introduction to some of the methods of the scanner class. Our intention in that video was to provide sufficient information to allow you to request and obtain data from a user. In this current video, we're going to build upon what we presented in the previous video. We'll take a closer look at Scanner and explore some additional methods available for objects created from the Scanner class. We'll also discuss the idea of what's called stream input, the idea of working with a stream of characters. Let's begin with a quick review of the Scanner class. In our previous video, we introduced Scanner with enough information to get you going. Recall that in order to use the Scanner class, you must import the Java util package. This is where the Scanner class definition resides. So Scanner is a class that provides methods for reading words or strings, numbers, and other types of data. In order to read integer data, we would use one of these four methods, depending upon the size of the number. In order to read floating point, we have methods for single precision and double precision. We can also read Boolean. Actually, Boolean is entered as a character string, spelling out the word true or false. With NextLine, we can read an entire string of characters. So we'll take a look at some examples of these methods actually being utilized. In order to invoke the methods, we need to first create a scanner object, which means we must invoke the constructor for the scanner class and associate the reference variable with the object that's created. The constructor is informed of where the stream is coming from. System_in refers to the standard input device, the keyboard. We also could use a file. In this video, we're going to continue to focus on the keyboard. So this statement is shown here, tells Java that this thing called keyboard is our scanner object, the reference variable to refer to the object, and it is associated with system_in. Look more closely at the scanner object methods. The four methods that we mentioned that relate to reading integer data are clarified here. In each case, we specify that we are reading an integer value. In each case, the method will read data from the input stream and convert it to an integer of the appropriate type. If the value that is encountered exceeds the capacity of the storage indicated here, then we have an exception that is thrown. For example, if I attempt to apply next byte and return an 8-bit value, but I've entered a value that is greater than can be represented in 8 bits, the system throws an exception. The thing to note, once again, is that we're reading from a character stream or an input stream and converting the value to an integer. Similarly, in dealing with next float and next double, we're reading from the input stream and returning a single precision floating point number or a double precision floating point number. These numbers allow for a decimal point. We could enter an integer value which would be acceptable. It could be converted to a floating point value, or we could enter a value that contains a decimal point. Next, Boolean receives as input a character string that must spell false or true, one of the two Boolean values, and this will be transformed and converted internally to a Boolean value. Now, the spelling of the character string for false or true is not case sensitive. Next line reads an entire line of input, a stream of characters that is converted into a string. We'll talk about the exact behavior of what is read in just a moment as we start to examine some examples. In our first example, we'll look at the use of next line to read a string and next int to read an integer. In this code, we've created two variables, name, which is a string object reference variable, and age, which will hold an integer. We define the scanner object, and then we prompt the user for a character string. Using the scanner object, we invoke next line, which is going to read the entire line. In fact, what next line does is it reads an entire line from the input source up to the new line character, returns that entire line as a value of type string. The new line character, although it is read, is not considered part of the returned object. But having read that new line character is significant because we're now positioned at the next line of input. On the other hand, next int will read one value from the input stream and convert it to an integer, returning that integer value. If the value entered by the user is not a legal integer, then next int will crash rather than prompt the user to re-enter the value. Now, the integer entered by the user must be followed by white space. Now, what is white space? White space consists of any characters that print or display as white space when written on white paper. Such characters would include spaces or blanks, tabs, or line breaks, the new line character. So let's look at this in action, and then we'll make some modifications. Prompted for a character string, we provide a value. Enter that, then we're prompted for an integer, and we'll enter a value here. The two values were both acceptable as being legitimate for the data types and for the operations performed, so we see on line 18 the effect of the printf method. Let's give it another try. And this time, in response to the age, let's provide a value that is not a legitimate integer. What happens is an exception is thrown. The exception is called input mismatch exception. On line 16, we had indicated that we wanted from the input stream something that could be converted to an integer and subsequently assigned to our integer variable. What was read was something that was not convertible. It could not be transformed or cast as an integer, therefore the system threw the exception. So let's look at a variation of the program which we've named multiple int values. The idea is we have an integer variable, but we're going to be prompting the user for more than one value. How is the system going to deal with that? Let's fire this up. Enter three integers. So we enter three integers. We'll say something like 20, and we'll put a space, 19, space, and 17. And notice that the values were returned as the first integer, second integer, and third integer, which means that lines 12, 15, and 18 kicked in to issue these displays. But in the meantime, in between, line 14 invoked next int, as did line 17. How was this able to work? Well, let's give you a little bit of an explanation with a graphic, and we'll discuss this in a bit of detail. In response to the prompt to enter three integers, the user typed in 20 and then a space, 19 and then a space, 17, and then hit the return or enter key, which caused the new line character to be entered in the stream. When the first next int was executed, it read the value from the beginning of the input stream up until it encountered white space. Hence, the value of 20 was returned in the first call to next int. In the second call to next int, it again read up to white space and returned the value of 19. In the third call, it read from where it was positioned again up to where it encountered some white space. In this case, the white space was the new line character. This caused the value of 17 to be returned. Now, the new line character was actually not read at this point. But this is how the system worked through this stream of input. Having seen how stream input is handled by the next line and next int methods, let's consider a different situation. Recall in our first example, we invoked next line first by asking for the name. Then we made a call to next int in response to a prompt for the age, for an integer. Suppose we reverse the order of these calls. That is, we attempt to call next int first and then ask for the name, calling next line. Let's give this a try and see what happens when we run it. So we're prompted for the age. This is on line 12. So on line 13, it's sitting there now waiting for us to enter the age. So we'll enter a value. Then on line 15, we're prompted for the name, and sure enough, that prompt comes out, but it immediately jumps to line 18 and executes the printf. What happened to the call to next line on line 16? We didn't have an opportunity to respond to this message or to this prompt to enter a name. Remember that in response to the prompt for an age, we entered the value of 45 and then hit the return key. This entered 4, 5, and the new line character. The call to next int read up until the new line character, the white space, and extracted the 45, but left in the buffer, or in the stream, that new line character. Then, when the call was made on line 16 for next line, it read everything up to and including the new line character. We didn't have a chance to enter any response to the prompt from line 15 because there was already something in the buffer or in the input stream that had not yet been consumed. Let's consider a modification to this program that would allow us to have an opportunity to respond to the prompt for the name. What we would need to do is to consume that extra new line character that was sitting in the buffer. So let's insert a new line here. And what we'd like to do is effectively invoke a call to next line. And we'd like to do that prior to issuing the prompt. So we'll insert that here. The purpose of this call to new line is to consume the new line character that was waiting in the buffer after the call to next int when the user entered an integer and hit enter. So this is just kind of a dummy operation just to get past that new line character and give us an opportunity to move ahead. So let's see what happens with this slight modification to the application. So we enter a value in response to the prompt for the age. This is the call to next int. We hit enter, and there's our prompt for the name, and it's waiting for us to respond. We respond, hit enter, and sure enough, that was actually read into the program and assigned to the variable name. So the extra call to next line simply got us past that kind of lingering new line character and allowed us to enter a fresh input line where the next line read all the way up to the return or the new line character. To ensure that you understand the concept of what's going on here, let's look at one more example along this line. In this particular application, what we're doing is reading two values of a particular data type using one of these next methods. And we do this a few times. In a single prompt, for example, on line 10, we ask the user to enter two whole numbers, two integers, and separated by some white space. On lines 12 and 13, we consume the values. So in two successive calls, we read something from the input stream, then read the next thing from the input stream. We continue by asking the user to enter two more numbers, indicating that these could have decimal points. So we then read these two values through two calls to next double. And then we proceed to use another method called next. And what next does is allows us to read a string, not consuming the entire line like next line does, but just reading a single string. So what we do here is prompt for two words, and then we invoke two successive calls to next to extract these values. Let's run this application and see how it works. We're asked to enter two whole numbers, so let's give a couple numbers, such as 20 and some white space, 19, entered on a single line, and through two successive calls to next int, we retrieve those values, again working on the same stream of values. Now we enter two decimal values, so I enter 10, and I enter 15.5. And notice they are both converted to double, hence the 10 that I entered is actually shown as 10.0. But again, the two values were read from the same line of input. Enter a couple of words, goodbye and hello. And again, through two successive calls to the next method, we read these two strings. And finally, we're asked to enter an entire line of text. And we enter that, and the entire line is consumed and assigned to a string variable. We'll conclude our examination of the scanner class by demonstrating two additional methods. In this program, we're looking at the next Boolean method and the next byte method. First, we're prompted for a Boolean value. Whenever we enter anything from the keyboard, it's going to be some kind of character data that has to be transformed into some internal data type. So even when we're prompted to enter an integer or a double, we're still typing in characters, and the appropriate methods are converting those characters to internal representations that conform to integer or floating point and so on. Well, with Boolean, it's the same way. We're going to enter a character string. So I'll enter false, spell it all in lowercase, and it was accepted and prompts for the next value. So let me simply enter a small integer value and move on. I'll run it again. This time I'm going to show the value for Boolean as being entered false, spelled all in uppercase. And that's accepted. But notice what got echoed was FALSE all in lowercase. The internal representation of false, we don't really know what that is, but whenever it's converted in reverse to take the Boolean value and render it for display purposes, it treats it as all lowercase. And the same applies for true. So the value that we enter as the character string for our Boolean values of true or false is case insensitive. Now, with respect to the small integer, I'm using the next byte operation. And when I do that, I'm limited to an 8-bit integer. So I can provide a value of 127, and that's fine. It's within the range of decimal values that can be stored within an 8-bit binary integer. Try another one. I'll try a negative 45, and that also is within the permitted range. And we'll give one more try here, and we'll try for an integer value, something like 278. And when we do this, things don't work out so well because we've entered a value that cannot be stored within an 8-bit binary integer. Therefore, we have that input mismatch exception that we examined earlier, and the program terminates. In this video, we examined a few additional methods that are part of the scanner class. This gives us the ability now to work with applications that could accept or operate on a variety of different data types. Also of interest was the idea of stream input data. So we explained how the methods in the scanner class operate on these input streams. Again, our source of input was the keyboard, the standard input device. But the scanner methods also operate on files. So this is useful information extending beyond just an interactive application where a user is providing data in response to prompts.